Booster 15 has just made Starbase even more thrilling with the most powerful static fire test to date. With rapid hardware progress, Flight 8 and the upcoming missions are set to launch in quick succession. The road to Starship's 8th flight and the 2nd of this year is wide open. Determination is at an all-time high as SpaceX pushes forward to address the unfinished objectives of the previous mission. A critical milestone in that preparation has just been reached. Booster 15 has successfully completed its static fire test. Following the booster's rollout to the launch pad, it was promptly lifted onto the orbital launch mount. By the afternoon of the 8th, road closures and key logistical movements signaled that a major test was imminent. The removal of the booster transport stand and OLM work platforms further hinted that this would be a particularly powerful static fire. By the morning of the 9th, venting from the OLM, the tower, and the tank farm indicated that the test sequence was underway. Propellant loading followed, with liquid oxygen filling the tanks completely and liquid methane reaching about a third capacity. Then, at precisely 9:51 a.m. Central, the test ignited into action. As expected, the water deluge system kicked in, releasing approximately 350,000 gallons of water to absorb the heat and pressure from the engines. And then, the moment arrived. 33 Raptor engines roared to life, unleashing over 7,000 tons of thrust. The burn lasted for approximately 8 seconds, making it one of the most powerful and sustained static fires ever conducted at Starbase. The impact of the test was dramatic. Compared to previous booster tests, the dust and debris cloud rose higher and more forcefully, closely resembling an actual launch. This suggests that SpaceX is now testing under near-flight conditions, an essential step in refining vehicle performance and validating the resilience of the launch system. Post-test observations confirmed no apparent issues with either Booster 15 or the ground infrastructure, reinforcing the success of the static fire. Shortly after, SpaceX shared spectacular imagery of the event captioned "Full Duration Static Fire Test of Super Heavy." Elon Musk himself reshared one of the images, emphasizing the name Starship Super Heavy Booster. With this test complete, the next phase of preparation is already underway. The launch tower's chopsticks were raised and lowered, followed by the retraction of the ship quick disconnect arm. The booster transport stand is expected to arrive shortly, ready to move B-15 back to the production site for a thorough post-test inspection. This will include assessments of the engines, fuel systems, and overall structural integrity. In the coming weeks, B-15 will be outfitted with its hot staging ring and flight termination system. Once all systems are in place, it'll return to the launch pad to await integration with Ship 34. Speaking of Ship 34, preparations for its next steps are also in motion. On the morning of February 9th, the ship test stand was transported to the production site. This is a key precursor to S-34's upcoming movement, which is scheduled for February 10th, with road closures set between 12 noon to 4 p.m., and again from 9 p.m. to midnight. The ship will first wait for Test Tank 16 to return before heading to the Massey test site. Like B-15, Ship 34 will undergo its own static fire test after spending time in Megabay 2 for engine installation. This upcoming test is crucial as SpaceX aims to address and improve upon past performance, particularly the anomalies encountered with Ship 33 during Flight 7. The ship's engines will play a vital role in several mission-critical tasks: achieving orbit, supporting payload deployment, conducting a relight test in space, and eventually assisting with controlled navigation and landing. If all goes according to plan, Ship 34's static fire test will take place within the week without requiring a scheduled road closure. Once completed, the vehicle will return to the production site for final checkouts and outfitting. This includes installation of the PEZ dispenser payload deployment system, simulated payloads, and the flight termination system. From there, it'll be transported to the launch pad for wet dress rehearsal testing alongside B-15. Meanwhile, another key element in SpaceX's ongoing testing campaign is Test Tank 16. After arriving at the Massey test site on the 4th of February, it has already undergone a series of evaluations, some of which were unexpected and highly intriguing. One particularly notable experiment involved a chopstick simulator system. This test setup, never seen before, appears to replicate the mechanisms of the actual launch tower's chopsticks. It suggests that SpaceX is actively developing catch and reuse techniques for future flights. The objectives of these tests likely include compatibility verification, pressure testing, and structural assessments. If successful, this research could pave the way for a two-stage recovery attempt as early as Flight 9 with Ship 35. Alternatively, it may indicate upgrades to the Super Heavy version 2 catching system. There's even the possibility that the findings will contribute to refinements on Chopstick's Tower B, further enhancing Starbase's launch infrastructure. Once Test Tank 16 completes its test campaign, it'll depart the Massey test site to make room for Ship 34's arrival and prepare for its next assignment. Are you ready for what's next? Let me know by responding "I'm ready" in the comment section down below. And don't forget to like the video and subscribe if you haven't already to our channel to stay up to date with SpaceX's incredible journey toward the future of spaceflight. As SpaceX continues its rapid advancements at Starbase, other players in the industry are also making strides. Rocket Lab has officially kicked off its 2025 launch campaign with a successful mission, marking an important milestone for the company. After a brief delay to avoid interfering with other vehicles, Rocket Lab launched an Electron rocket at 3:43 a.m. Eastern on the 9th of February, carrying 5 Internet of Things satellites for Kinéis into orbit. Just over an hour after launch, the satellites were successfully deployed, advancing the developments of Kinéis's growing satellite constellation. This mission is the 4th of 5 that Rocket Lab is executing for the French company, aimed at creating a constellation of 25 nano-satellites in low Earth orbit. The final launch in the series is expected to take place within the next few months, allowing the entire system to become fully operational by mid-year. According to Rocket Lab's mission description, the Kinéis network will enable global connectivity by allowing any object anywhere in the world to transmit useful data to users in near real time. The system's applications range from tracking and monitoring to alerting users of critical updates, offering a decision-making tool that optimizes activities while reducing risks. For Rocket Lab, this launch represents an exciting start to what is shaping up to be a busy year. Throughout 2024, the company launched 16 missions, including 14 successful orbital launches, securing its position as the second most active launch provider in the United States, second only to SpaceX. This year, Rocket Lab is looking to ramp up its launch cadence even further. Additionally, the company is making strategic moves to compete in the small satellite launch sector, offering services similar to SpaceX's increasingly popular rideshare program, which has attracted a growing number of customers looking for cost-effective access to space. However, despite its promising trajectory, Rocket Lab still faces significant challenges. While this month's successful launch is a positive step, the company did not conduct any launches in January, which could create time pressure if it aims to increase its launch frequency in 2025. Additionally, Rocket Lab must focus on advancing its next-generation rocket, Neutron, which is expected to make its debut in the coming months. NASA and General Atomics have recently achieved a significant milestone in the development of nuclear thermal propulsion technology, or NTP for short, a breakthrough that could revolutionize deep space exploration. As the push for Moon and Mars exploration intensifies, both the U.S. government and private space companies are seeking faster and more efficient ways to travel through space. Given the vast distances involved, nuclear propulsion has long been considered a game-changing technology that could significantly shorten travel times to Mars and beyond. Earlier this month, General Atomics Electromagnetic Systems, or GAEMS, in collaboration with NASA, conducted a critical test of the NTP reactor, evaluating the durability of the system's fuel under the extreme conditions of space. This test represents a significant step forward in demonstrating the feasibility of nuclear propulsion for deep space missions. The results of the test appear to be highly encouraging. General Atomics President Scott Forney stated, "We're very encouraged by the positive test results proving the fuel can survive these operational conditions, moving us closer to realizing the potential of safe, reliable nuclear thermal propulsion for cislunar and deep space missions." During the experiment, General Atomics subjected fuel samples to 6 thermal cycles using hydrogen, rapidly increasing temperatures to an astonishing 4,220 degrees Fahrenheit or 2,326 degrees Celsius. This extreme heat simulates the conditions the nuclear fuel would experience in space, ensuring it can withstand the intense demands of propulsion. In addition, the company conducted further testing on protective features, gathering valuable data to enhance the durability and efficiency of future nuclear propulsion systems. Christina Beck, VP of General Atomics Nuclear Technologies and Materials, emphasized the significance of this achievement, stating, "To the best of our knowledge, we are the first company to use the Compact Fuel Element Environmental Test, or CFEET, facility at NASA MSFC, or Marshall Space Flight Center, to successfully test and demonstrate the survivability of fuel after thermal cycling in hydrogen representative temperatures and ramp rates." With these promising results, the NTP system is proving to be 2 to 3 times more efficient than conventional chemical rocket engines. If progress continues at this pace, NASA aims to conduct an in-space demonstration of nuclear thermal propulsion by 2027. What do you think of this breakthrough? Do you believe nuclear propulsion is the key to reaching Mars and beyond? Let us know in the comments section down below, and stay tuned for more exciting updates on the future of space exploration. When it comes to speed, especially in terms of progress, nothing can compare to the pace seen with S34, especially as it just underwent a powerful test immediately after being moved, another significant step toward Flight 8. Just a few days ago, Booster 15 shook up Starbase with a powerful static fire test, marking a major step forward in Flight 8 preparations. With that milestone completed, all eyes naturally turned to the remaining piece of hardware for Flight 8, Ship 34. Before this, the ship transport stand had already arrived and was promptly moved into Mega Bay 2. By the end of February 9th, S34 was lifted onto the stand and then transported to Massey for testing. To be honest, I didn't expect S34 to undergo testing immediately after the move. But to my surprise, everything happened much faster than anticipated. Supporting this, a road closure schedule was posted for February 12th, with closures from midnight to 4 a.m., and again from 6 p.m. to 10 p.m. Initially, it was uncertain whether these closures were for Test Tank 16 or S34, but one thing was clear. S34 needed to complete testing soon to stay on track for Flight 8. By the morning of the 11th, the first signs of an upcoming test were evident, as S34's flaps were deployed one by one. By the afternoon, heavy venting was observed at Massey, lasting well into the evening along with the fuel loading process. Then, at approximately 8:15 p.m. Central, S34's engines roared to life in a powerful static fire test. Thanks to the flame trench, the test was well controlled despite the intensity. Observers estimated that 6 engines ignited, generating around 1,400 tons of thrust. Notably, because of the flame trench, this test lasted longer than any previous S34 static fire, with the burn time stretching to roughly a minute, pushing the engines to their limit. A surprising moment came at the end of the test when a loud explosion echoed across Starbase. This reminded many of the post-landing sounds from SN15's successful flight. While it's unclear whether this was a minor anomaly or just residual effects of the test, it certainly sparked discussion. Feel free to share your thoughts in the comments section down below. With this milestone completed, S34 is expected to undergo at least one more static fire test, potentially focusing on its in-space reignition capability. This was a key objective tested during Flight 6, but was missed during Flight 7. If SpaceX proceeds with this additional test, it would be a crucial step in refining Starship's ability to relight engines in orbit. Visually, this test stood out in a unique way. It was conducted at night, marking the first time SpaceX has done so for a ship static fire. While the darkness obscured the surrounding scenery, it also made the test itself look even more dramatic. The contrast of the glowing exhaust against the night sky created a stunning visual effect. Truly a sight to behold. For those looking for high-quality footage of this event, as always, Starship Gazer provided some of the best camera angles. If you appreciate their work, be sure to check out their X account and support them. They're consistently delivering some of the most breathtaking images and videos from Starbase. Returning to S34, post-test inspections have reported no significant damage, confirming that the test was a success. With this, S-34 has essentially completed its individual testing phase and will soon return to the production site. This time, however, SpaceX is expected to perform even more thorough inspections on the engine system and structural components. Given past flight data, the company is taking extra precautions to address previous issues and prepare for future attempts to catch Starship with the Megazilla arms. Following these final checks, S-34 will receive key installations, including the PEZ dispenser payload deployment system, a simulated payload, and the flight termination system. Afterward, it will be transported to the launch pad for integration testing with B-15. Overall, Flight 8 preparations are moving forward at a promising pace, making a February launch increasingly feasible. Of course, the final timeline will still depend on SpaceX's regulatory approvals following Flight 7, particularly with the FAA and other agencies. So what do you think? Will Flight 8 launch this month? If you're optimistic, type this month in the comments section down below. And don't forget to like the video and subscribe to our channel to stay up to date with SpaceX's groundbreaking developments. Besides preparations for Flight 8, Starbase has also witnessed the end of the V1 era. Yes, SpaceX has fully transitioned to V2 this year. However, one last remnant of the V1 era remained, Starship S-32. At this point, it had no role to play in the program's future. So, on the 7th of February, it was moved into high bay, where it was presumably cut into smaller sections. By February 10th, the first section, likely part of S-32's aft LOX section, was taken out. The next day, the 11th, 3 more sections appeared. One from the aft section where the flaps were attached, another that seemed to be the methane section, and finally the payload section. The nose cone is expected to be removed as well. It's clear that SpaceX is officially closing the chapter on version 1. Over the past year, we've seen the systematic elimination of B4, S26, B14.1, and now S32. The last remaining piece of V1 hardware is a booster. Regardless of their retirement, we must acknowledge the role of these vehicles in SpaceX's journey, culminating in Super Heavy's landing attempts with the Megazilla arms and the controlled vertical ocean landing of the ship. But as the V1 era ends, a new era begins, one where Starship will not only fly more frequently, but also be larger and more powerful. 2025 is shaping up to be the year of version 2. And by late this year or early next, we may even witness the first appearance of version 3. Are you ready for that? Meanwhile, NASA and SpaceX are making significant efforts to bring back the 2 Starliner astronauts. To prevent further delays, the 2 organizations have agreed to swap Dragon capsules for the upcoming Crew 10 mission. On the 11th, they announced that Crew 10 will now use the Crew Dragon Endurance instead of a new capsule which was originally planned for this mission. Endurance was initially assigned to the Axiom 4 mission, scheduled for the second quarter of this year. This spacecraft has already proven its reliability, having flown Crew 3, 5, and 7. Over the coming weeks, it will undergo refurbishment, stacking, fueling, and final integration at SpaceX's Kennedy Space Center facility before launch. Because Endurance is already a flight-proven vehicle, it is more prepared than a brand new Dragon. Had SpaceX continued with the original plan, Crew 10's launch could have been delayed, which would have had serious implications for the 2 Starliner astronauts who have been aboard the ISS since June of last year. Steve Stitch, NASA's Commercial Crew Program Manager, commented on the decision, saying, "Human spaceflight is full of unexpected challenges. We greatly benefit from SpaceX's commercial efforts and their proactive approach in having another spacecraft ready for us to assess and use in support of Crew 10. With this adjustment, SpaceX and NASA have now finalized a launch date for Crew 10, March 12th, earlier than the previous late March target. Once Crew 10 arrives at the ISS, Crew 9 will begin the handover process before returning to Earth a few days later. Crew 9 consists of 4 astronauts, including NASA's Nick Hague and Roscosmos's Alexander Gorbanov, as well as the 2 Starliner astronauts who have been stranded in orbit for more than 6 months due to Boeing Starliner's continued failures. This situation has been highly controversial, as it highlights the challenges and delays that have plagued Boeing's Starliner program. NASA and SpaceX's swift decision-making and flexibility in this matter once again underscore Dragon's crucial role in ISS operations. Let's all send our best wishes for the safe return of Crew 9. Meanwhile, Crew 10 will feature a 4-person crew as usual. The team includes 2 NASA astronauts, Anne McClain, the commander, and Nicole Ayers, the pilot, alongside JAXA astronaut Takuya Onishi and Roscosmos's cosmonaut Kirill Peskov. As for the Dragon capsule swap, it remains unclear whether this change will affect the Axiom 4 mission. Most likely, Axiom 4 will now use the new Dragon capsule originally intended for Crew 10. The Axiom 4 crew includes 4 astronauts from 4 different countries: American astronaut Peggy Whitson, Indian astronaut Shubhanshu Shukla, Polish astronaut Slavits Uznansky, and Hungarian astronaut Tibor Kapu. Let's see how these upcoming Crew Dragon missions unfold. And now for our last bit of today's update, let's head on over to China on the latest launch of a new Long March variant. On the 12th, China successfully launched the Long March 8A rocket, an upgraded version of the Long March 8. The mission lifted off at 4:30 a.m. Eastern from the Wenchang Satellite Launch Center, carrying the second batch of satellites for China's national satellite constellation, Guowang. Just over an hour later, the China Aerospace Science and Technology Corporation confirmed the mission's success. This launch marks another step in the expansion of the Guowang satellite constellation, which remains largely classified. Some experts speculate that Guowang is China's response to the US GPS system, though its full capabilities and purpose are still unknown. The Long March 8A is an evolved version of the Long March 8, which debuted 5 years ago. Standing at 50.5 meters tall, it features a 5.2 meter diameter payload fairing, a takeoff thrust of 480 tons, and the ability to carry up to 7 tons into sun-synchronous orbit. Originally, both the Long March 8 and 8A were designed with reusability in mind. However, China later canceled those plans and instead shifted focus toward reusability efforts on future rockets, including the Long March 9, 10, and 12. Going forward, the Long March 8 and 8A are expected to support a high launch cadence, primarily operating from Wenchang Launch Center on Hainan Island. Meanwhile, this mission marks China's 7th orbital launch of 2024. The country has set an ambitious goal of reaching 100 launches this year, with major priorities including the continued expansion of the Tiangong space station and further development of reusable launch system. For Starship enthusiasts, the 6-legged orbital launch mount system, along with the powerful water deluge system beneath it, has become a familiar sight. This combination has proven to be highly effective. However, in the long run, SpaceX will need a completely redesigned system, featuring significant upgrades to the launch tower, the OLM, and, most importantly, the addition of a flame trench system. But why were these systems chosen in the first place, and how are the upgrades progressing? One of the most significant developments at Starbase since last year has been the construction of Pad B, and now it's reaching its final stages. When discussing Pad B, the first thing that comes to mind is the flame trench system beneath the orbital launch mount. This is a major change compared to Pad A, and for good reason. Flame trench systems have been a staple of NASA's launch infrastructure for decades, helping to direct and dissipate the immense energy released during rocket launches. SpaceX has already tested a version of the system at the Massey test site, and the results have been promising. In fact, during an interview with Everyday Astronaut last year, Elon Musk hinted at the eventual implementation of a flame trench system for Starship. The benefits of this system are clear. A flame trench provides an angled surface that directs the exhaust away from critical infrastructure, reducing direct impact on the launch mount and surrounding structures. Additionally, it works in tandem with a high-powered water deluge system to further mitigate heat and pressure. To construct this system, SpaceX has already excavated a large space beneath the OLM at Pad B. This area will first be reinforced with a solid concrete foundation before the installation of a flame bucket system, which will be integrated with the water manifolds. Unlike conventional flame trenches that direct exhaust in a single direction, SpaceX is implementing a dual flame trench design, allowing the energy from each test and launch to be safely dispersed into 2 directions. This setup will greatly reduce wear and tear on the launch pad, making it more sustainable for long-term high-frequency Starship launches. As SpaceX scales up Starship operations, this will be critical, especially when future versions, such as V2 and V3 versions of Starship, introduces even greater thrust and structural enhancements. The decision to switch to a flame trench design stems from the challenges faced with the existing system. Pad A currently uses a water-cooled steel plate system, also referred to as a reverse shower system. This consists of steel plates perforated with small holes, through which water is pumped at high pressure during ignition to absorb heat and dampen the force of the engines. This system was introduced after the damage caused during Starship's first test flight, and it successfully prevented the kind of catastrophic ground erosion seen in Flight 1. However, this method has its limitations. While it offers some protection, it does not actively redirect the